This video will cover homework. Its name is 0.314 practice number 1. So we're going to go through some equations that we need to know how to solve already to understand the college algebra class. First question is, if 4x plus 21 is equal to x, how we can solve this equation? We will subtract x's on both sides. So 4x minus 1x is 3x. Bring down the 21, and x minus x is just a 0. Then I subtracted 21 from each side. So I get 3x is equal to a negative 21. When I divide each side by 3 to isolate the x becomes just negative 7. And we're just going to choose A, and then the answer is negative 7. When we put this answer, it will be correct. For the second question, we have our second question is 3 minus x is equal to 3x plus 7. We need to put all x's on one side, and we have to put all numbers on the other side. So I will add x's on both sides. Then I get 3 is equal to 3x. One more x is 4x plus 7. Now we can subtract 7 on both sides. So that's a negative 4 is equal to a 4x. Now to isolate the x, we can divide each side by 4. X is equal to negative 4 divided by positive 4 is just negative 1. X is equal to a negative 1 is the answer we're looking here. So I'm going to mark A, and I will tell them that the answer is equal to a negative 1. Negative 1. For the next question, we have 5 parentheses, 4 plus 2x equals 9 parentheses x minus 10. Now 5 times 4 is 20, 5 times 2x is 10x, 9 times x is 9x, 9 times 3 is 27. We need to put the x's together, so we will subtract 9x from each side. So 20 plus 1x is equal to a negative 27. And then when we subtract 20 from each side, x will be finally isolated on the first side. And when I combine these two like terms, they are both negative, so I need to add them up. And their common sign is negative. So x equals negative 47 is the answer we expect here. And then here, I am going to place negative 47 inside the braces to submit the answer. For the next question, we need to solve 4x minus 8x plus 6 is equal to 6x minus 46. I need to combine everything on each side. So I have 4x. When I apply the negative to this parentheses, it will become negative 8x. And then this will become negative 6. So a negative sign changes everybody's sign if it is before a parentheses. Is equal to 6x minus 46. Now on the first side, I can combine the 4x and negative 8x. That makes total of negative 4x. Minus 6 is equal to 6x minus 4x. And now let's just subtract 6x on both sides. So we can have all the x's on one side. Both of them are negative, so I need to add them up, which becomes 10x. And their common sign is negative, so it will be a total of negative 10x. Bring down the minus 6 and make it equal to a negative 46. Next, we will add 6 on both sides. So that's negative 10x is equal to a negative 40. Then we will divide each side by negative 10. So x is finally isolated on the first side. Negative divided by negative is positive, and 40 divided by 10 is just 4. And this is how we solve question number 4. For question 5, we have 4 over 5x plus 4 equals 1 over 5 plus 1 over 5x. There are so many different ways to handle these questions, but whenever the questions involve fractions, I like to clear all fractions and make my problem look like a linear equation. So here, this one has a denominator of 5, and the other two terms, they have the denominators of 5. So if I just multiply every single term by 5, let's see what happens. So this will be multiplied by 5. 4 will be multiplied by 5. 1 over 5 will be multiplied by 5. And 1 over 5x will be multiplied by 5. The advantage of doing this is now the top 5 always cancels the bottom 5. So this one just becomes 4x, no more denominator. On the second term, 4 times 5, because there is no denominator here, we have to actually multiply. 4 times 5 is 20. On the right side, again, the top 5 is going to cancel the bottom 5, and all we're going to get is a 1. For the last term, top 5 will cancel the bottom 5, and all I'm going to end up is just 1 times x, which is simply an x. So no more fraction in my equation, and it's easier to handle for me. I can subtract x on both sides. So 4x minus 1x is just 3x plus 20 is equal to a 1. Now subtract 20 on both sides. 3x is equal to a 1 minus 20 is just negative 19. To isolate the x, now we're going to divide each side by 3. So x will be equal to negative 19 out of 3. And this is how I can solve this question. I will mark A, and I will tell them that the answer is a fraction. And on the top, I can just write negative 19. And at the bottom, I can just write 3. And then when I check my answer, they will say that it is correct. Question 6 is a similar question because it has fractions. So let's just open some room and copy the question. So question 6 is 3 over 4p is equal to 4 over 5p plus a half. Now the scenario is here a little bit different because this one has a fraction of the denominator of 4. This one has a denominator of 5. So they are not the same numbers. Because they are different denominators, we need to find their least common multiple so we can clear both of them. So 4 and 5, their least common multiple is 20. So if I want to clear the fractions here, I must multiply every single term by 20. So this will be multiplied by 20. This will be multiplied by 20. And 1/2, the last term, must be multiplied by 20. So let's see what's going to happen now. I can't just simply clear 20 and 4 anymore because they're not the same numbers. But fractions, they mean division. So I can divide 20 by 4. 20 divided by 4 is just 5. So now I have 5 times 3p, which becomes 15p. Again, we're going to do a very similar action here. First, 20 divided by 5 is 4. Now all I have to do is 4 times 4p, which will become 16p. Similarly, 20 divided by 2 is 10. And all I have to do is now 1 times 10, which is 10. So no more fraction, and it's such an easy problem to handle. We will subtract 16p from each side. So these two cancel out. 15 minus 16 is just negative 1p is equal to 10. And then if we just divide each side by negative 1 to make it p a positive number, 10 divided by negative 1 is just negative 10. And this is how I can solve for p for this problem. So we're going to mark A, and we're going to tell them the answer is negative 10. For question 7, we have another fractions involved. So we have x plus 3 over 6 plus x plus 6 over 5 is equal to 1. again, first thing I do is I check the denominators. This is a 6, this is a 5, and I want to clear both of them. So I need to think about their least common multiple. Their least common multiple is 30. So please make sure that you multiply every single term by 30. So this will be multiplied by 30, and second term will be multiplied by 30, and then the last number will be multiplied by 30 to be a fair person. 30 divided by 6 is just 5. So now this 5 will be distributed over x plus 3. So let's just do it. 5 times x is 5x. 5 times 3 is 15. 30 divided by 5 is 6. Now this 6 will be distributed over x plus 6. 6 times x is 6x. 6 times 6 is 36. And this is equal to 1 times 30, which is 30. No more fractions, and we just have a straight linear function that we can easily combine the like terms and solve for x. I will combine 5x and 6x. When I combine positive 5x and positive 6x, I will have total of 11x's. Then I will combine positive 15 and positive 36. So when I add them up, that's going to give me a total of 51. And this will be equal to 30. Subtract 51 on both sides. 11x is equal to a negative 21. Divide each side by 11. So x is equal to a negative 21 out of 11. And this is how I can solve this problem. I will mark A, and I will tell them that the solution set is negative 21 divided by 11 equal 11. Question 8 from the same assignment has another fractional equation which looks like 1/4 plus 4 over x. So this is very different now because x is in the denominator, equals to 5 over 12. Now the approach that I have been using so far is not going to work for this problem because x is in the denominator, and I can still do it with the least common multiple, but it will be kind of awkward. So instead, I'm just going to go ahead and change this fraction to an equivalent fraction with a denominator of 12. So 1/4 is the exact same fraction as 3 out of 12 because I can multiply the top and bottom by 3. So if I multiply top and bottom by 3, it becomes 3 out of 12, which is the same fraction as the original one. So this one will be known as just 3 out of 12. 3 out of 12 is the new look for 1/4. Now I want to subtract 3 out of 12 from both sides of the equations. So these two cancel out, and all I get is here 4 over x. When we are subtracting two fractions, if they do have the common denominator, which in this case they do, all I have to do is 5 minus 3, and 5 minus 3 is just 2, and their common denominator is 2 out of 12. So if you subtract 3 out of 12 from 5 out of 12, the answer is just 2 out of 12. Now, I would like to do cross multiplication to solve for x now. So here's how we do the cross multiplication. 2 times x is 2x. 4 times 2x is 48. To solve for x, we just have to divide each side by 2. So x is equal to 48 divided by 2 is just 24. This is how we do this question. X must be at 24. So I will mark A, and then the solution set is just number 24. We will mark this answer on the homework. For question 9, we don't have a linear equation problem anymore. We have a factoring problem. So this is a review from the very first homework. I need to factor x squared minus 3x minus 40. This is a trinomial, and it's an easy type of trinomial because there is no number before the x squared. So I will just focus on the last number, which is negative 40. I need two numbers. When I multiply these two numbers, I must get negative 40. So let's make one of them positive. Let's make other one negative. When I multiply them, the answer is a negative 40. But when I also add them up, when I combine the positive 5 and negative 8, the sum is negative 3, it must be in the middle. So if I have to check the second part, because when I add them up, if their sum is not negative 3, these are not the numbers that I'm looking for. So one factor will be x plus 5, and the other factor will be x minus 8. So we will tell them that we have two factors here. One factor is x plus 5, and then the other factor is x minus 8. Question 10 is another factoring problem, but it is a hard type this time because w squared, the quadratic term, is not alone. There's a number here which makes the process a little bit tricky and longer. So the question starts with now 5w squared minus 14w minus 3. Okay, for this question now, first I will bring down this 5w and w, because when I multiply them, I get 5w squared. The last number is 3. The only way to break down the 3 is 1 times 3, but I just don't know if 1 goes here and 3 goes there, or 3 is at the top and 1 is at the bottom. I have to just try and check. So I kind of check it in my head already. So I know that 1 has to go to the top, 3 has to go to the bottom. Since it's a negative number, one of them has to be positive, one of them has to be negative. So when I multiply them, the product is a negative 3. I still don't know if this is what I'm looking for, so I have to now multiply these two, and it gives me a negative 15w. Now I will have to multiply these two, which will give me a positive w, and when I combine them, that's negative 14w, which is in the middle. So exactly these are the factors that I'm looking for. First factor will be 5w plus 1, and then the second factor will be w minus 3. Once you FOIL them again and combine the like terms, you must get your original problem. So that might be your checkpoint. And since I'm very sure about my answers, I'm going to go ahead and plug it in. 5w plus 1 and w minus 3 is the expected answer here. For the next question, 11, now we're going to solve a quadratic equation using factoring. So it doesn't say factor anymore. It actually says solve. So the equation is z squared plus 2z minus 15 equals to a 0. A quadratic equation can be solved by factoring. So first we're going to focus on our trinomial. This is easy type 1. So we will factor this, and then we're going to set each factor to 0 to solve for z. So this is a negative 15, and I need two numbers. When I multiply them, their product is negative 15, like these two numbers. When I multiply them, their product is negative 15. And when I add them up, their sum is a plus 2. So this is the only combination of these two numbers. And then we're just going to place the variables here, z plus 5 and z minus 3. These are the two factors. Because now we need to solve, this is set to a 0. We're going to take each factor and set it to a 0. Subtract 5 on both sides. This gives me z equals negative 5. And then add 3 on both sides. And then this one gives me z equals positive 3. So this question here is going to have two solutions, like many quadratic equations. There are some that there is no solution. There are some quadratic equations that they have only one solution. But most quadratic equations, they will have two solutions. For question 12 on this assignment, we have another solve by factoring type problem. It's a difficult type factoring because the quadratic term has a number in front of it, like 7x squared minus 34x minus 5. This is set to a 0, so we need to solve for this. First thing is, again, how do I factor this? I'm going to use the same method that I have been showing you. 7x and x. When I multiply them, their product is 7x squared. For 5, my only chance is 1 times 5. That's a good thing. So I'm gonna place the 5 here, place the 1 here, but I need a -5. So one of them has to be negative, one of them has to be positive. So when I multiply them, the product is -5. Now, I'm still not sure if I got everything right with the signs and with the positions. So I will multiply these two. It gives me a -35x. Then I multiply these two. It gives me a positive 1x. And their total is -34x, which is right in the middle. I see this in the middle. That's a good sign. That means my factoring is correct. 7x plus 1 is the first factor I'm looking for. X minus 5 is the second factor I'm looking for, and this is set to 0. Now, to solve for x, each one individually will be set to 0, and we're going to solve for x, each one, and then x minus 5 will be set to 0, so x will be isolated as +5. So this question has two solutions. One solution is -1/7. And if you read these small directions for these homework questions, it says put a comma between your answers if you have more than 2 answers. But you have to make sure that you are putting the comma in the right spot, because the first one is a fraction. And then the second one is 5. We have two solutions, -1/7 and +5. Next question is question 13. It's again factor, solve by factoring type of problem. 3a squared minus 48 is equal to 0. This is not a trinomial anymore, so I can't use the technique that I have been showing you. This is not a trinomial. So first thing I can do is, I know that 3a squared and 48, they both have a 3 in common. So applying the GCF method really makes all your factoring problems easier. So if you see any common factor, first take it out. So I'm going to take out 3 from the problem. So the question simplifies to a squared minus 16. Again, 3 times a squared is 3a squared. 3 times 16 is 48. But when you took the 3 out of each of these terms, you end up with a squared minus 16 to factor. So this one is a to the second power, and this one is 4 to the second power. So I'm going to bring down the 3, which is not going to affect my answers, but I'm going to still bring it down to be neat and nice. We have a formula. Whenever the question looks like difference of two squares, the formula says I need to factor them as a plus 4 and a minus 4. So they always bring me two factors, one with a plus, one with a minus. Because this number has no variables attached to it, this is not going to bring any solution, so you can simply ignore it. Or you can just divide each side by 3 to get rid of the number, and then your problem just becomes a plus 4 times a minus 4 equals 0 divided by 3 is just a 0. Now, a plus 4 will be set to 0, and this gives me a equals -4. A minus 4 will be set to 0, and this gives me a equals +4. So we're going to have two solutions in this problem. One solution is +4. Again, the order is not important. You can put them in any order you like. One solution is +4. The other solution is -4. For question 14, we have a little bit more work than the others because the question doesn't come as organized as we like. So it's x parentheses x minus 16 plus 63 is equal to a 0. X times x is x squared. X times -16 is -16x plus 63 is equal to 0. So first, we had to put the question in the right form so we can go ahead and factor this. Now, this is a quadratic equation which I can factor. I need two numbers that I multiply and I get 63. The first two numbers comes to my mind is 7 times 9 is 63. If I keep them positive, when I multiply them, the result is still positive 63, which is nice. But when I add them, the sum is plus 16, but the question wants a negative 16. Therefore, we have to take them both negative numbers. So when I multiply them, their product is still a positive number, but when I add them up, where sum is now negative 16. Therefore, first factor is x minus 7, and the other factor is x minus 9. Because this is not a factoring problem, this is an equation, and we need to solve this for x. Each one will be set to a 0 separately. So if I set this to a 0, it must be a 7 because 7 minus 7 is a 0. And then if I set x minus 9 to a 0, x must be 9 because 9 minus 9 is a 0. So this question is going to have two solutions. One solution is positive 9, and the other solution is positive 7. And this is how we put our two answers to this problem. The last question on this assignment is similar. So 6 parentheses p squared minus 1 is equal to f5p. So since this is not as organized as we liked, we're going to do our best to put it in the format that we are familiar with. 6 times p squared is 6p squared. 6 times negative 1 is negative 6. And we will bring the 5p to the other side as negative 5p. Since there is nothing left on the right side, this is a huge 0. Now, for quadratic equations, this is not the correct order. Always we need to have the quadratic term, and then I need to have the negative 5p in the middle, and the independent number negative 6 must be always at the end, and the equation must be set to a 0 to be able to factor and apply the zero product property to solve this equation using factoring. So we're going to focus on factoring this trinomial now. Again, this is going to be a little bit harder than normal because 6 has a lot of factors, but let's try. If I do 2p and 3p, because when I multiply them, it's 6p squared. And then this is, I can do 1 times 6, I can do 2 times 3. I just don't know which one is going to work. So I'm thinking that if I do 1 times 6, the difference is 12 and 3. It's going to be too much. So I want to do the 2 and 3 option again. So if I put the 2 here, put the 3 here, this gives me a 4, this gives me a 9. So there's a way to get a 5 from 4 and 5. So since this is negative 6, I'm going to make this a negative number, make this one a positive number. So when I multiply them, it's still a negative 6. But we have to again do what we have been doing. Multiply these two. It's a positive 4p. Multiply these two. That's a negative 9p. So when you combine them, their sum is negative 5p, which is in the middle. That means we were able to get the correct factors. So here, one factor we need is 2p minus 3. And the other factor I need is 3p plus 2. And this is equal to 0. This is only possible if 2p minus 3 is 0 or 3p plus 2 is a 0. To solve for p here, we're going to add 3 on both sides. 2p is equal to a 3, and divide each side by 2. This gives me p equals 3 over 2. Now here, negative 2, negative 2. 3p is equal to a negative 2. Then we're going to have to divide each side by 3. So this gives me p is equal to negative 2/3. So this question has two solutions. We will tell them that one solution is 3 over 2. And then the other solution is negative 2 over 3.